Three.
Hi, my name is Vamsi and today I am going to put forth my views on the topic of reverse engineering based on IEEE paper. Before starting to discuss this topic, let me briefly explain what is reverse engineering. Reverse engineering is the process of taking a software program's binary code and recreating it so as to trace it back to the original source code. Is being widely used in computer hardware and software to enhance product features or fix certain bugs. In general, reverse engineering is used to cracking software protection, advanced exploitation, advanced exploitation. For example, to know if a code to know if a code is copied or to prevent the security protocol disclosures. And also reversing undocumented operating system APIs, virus and malware analysis, binary code auditing. Now, based on this topic, here UML sequence diagrams plays an important role in software engineering. They help software engineers understanding existing software through the visualization of interaction between its objects. They can also be used in testing activities. When sequence diagrams are either absent or inconsistent with the current code, as it is the case for many legacy systems, reverse engineering can be used to extract more accurate models. A dynamic approach is better suited to the reverse engineering of sequence diagrams of object oriented systems because of inheritance, polymorphism, and dynamic binding. This approach consists of three steps: traces collection, merging traces, developing a sequence diagram based on step 1 and step 2 to understand how functionality of system works and analyze its source code. As discussed in the current paper, library is a good example which allows to study about a complete set of functionalities, adding customers, titles, copies, making reservations, and proper analysis and design documents, including sequence diagrams under the author's supervision. The size of systems excluding comments and blank spaces. Furthermore, it was developed independently from the current work in the framework of fourth year engineering project. This system is not only implemented in Java, but it distributed several client nodes can communicate with unique server node. And the middleware of the network communication is RMI. We then find ourselves in typical context where the reverse engineering of sequence diagrams can be useful to check the consistency of the code within the design. We carefully compare reverse engineered and designed sequence diagrams and determine the cause of discrepancies, whether they are due to inconsistencies, implementation, decisions, or making in our algorithm. All the classes in the library system have been instrumented using this strategy. Two exceptions are classes belonging to the graphical user interface and classes implementing a database management system for storing instances of entity entity classes, copy, title, etc. The reason is that we are not interested in the reverse engineering of those subsystems as their object interactions are usually not described in the analysis design sequence diagram, which focus on interactions among application objects. As a result, this methodology provides a reverse engineered scenario diagrams, partially sequence diagrams for specific use scenarios for dynamic analysis. It does so by accounting for issues related to distribution. Though our solution is specifically to the Java context, many of its components can be reused and tailored to other platforms. A more general methodological contribution of our work is where we specified our reverse engineering work in our reverse engineering process by using meta models as UML class diagrams and transformation rules as constraints in object constraint language. Our review, our review of the literature has shown that many reported works were not described in sufficient details and formality. So as to allow formal comparisons and improvements, our approach enables the specification of what information traces contain a logical level and its mapping to formal abstract model. In our case, future work can then be compared by comparing meta models and mapping rules. Another advantage is that our meta models and rules can then naturally be used in specifications to develop tool prototypes. The initial classes of our meta models, it is also important to note that if our reverse engineering process were to be adapted to different distribution middleware, the meta models or and rules would remain unchanged. For example, according to a global clock instead of local clocks, in the case of asynchronous remote communications, only the instrumentation would be then affected. Okay. In order to minimize the impact of source code, instrumentation and its related drawbacks, we use bytecode of Java systems. This brings a lot of benefits both in terms of overhead and practicality of instrumentation and enables the clear specification of instrument and application code. We provide here a set of precise aspects including some that deals with distribution issues and in the context of Java and RMI. If a different middleware were to be used, the aspect code might have to measure time in the different way and all time related statements would change. Also, all the aspect code statements referring to the java.rmi interface would change to refer what interface is defined by the new middleware to interact with remote objects. A change of language would of course have a much more serious effect as a different aspect waiver would have to be used, possibly following a different syntax. We performed a case study on a distributed library management system developed in Java using RMI scenario diagrams. Uh, and its conformance to the design and inform us about implementation choices. A carefully a careful study of the execution times in this system has shown that the overhead introduced by the instrumentation is significant, but should not prevent the reverse engineering of scenario diagrams in most practical situations. Detailed results were reported for a representative scenario in terms of absolute and relative overheads due to instrumenting RMI remote calls, local calls, and control flow constructs. Future work includes the automated derivation of sequence diagram, that is, merging of scenario diagrams. The automated comparison of complete sequence diagrams for testing and quality assurance purposes, and the use of a static analysis technique to capture the control flow inside methods more accurately than through instrumentation. That's all. Thank you.